Thank you and good afternoon. We'll technology is always exciting. All right. So I don't actually know much about Grenfell, other than what the rest of you probably know from the news. My only claim about knowing anything is I received a phone call, which at my local time was 4:30 in the morning. It was one of my friends here who said, "What do you think about the fire?" And I said, "What fire? You just woke me up." And at 5 a.m. I got another call from another friend who said, you were right. I said, "About what? You've just woken me up." And I looked out the window and saw the smoke. And that's about as close as I got to Grenfell. Are Australian buildings safe? This is a question that seems to be in the news a lot lately. And it's not just a fire thing. We read a couple of days ago in The Age about balustrades and balconies breaking, falling off, and shattering. How safe are our buildings? I'm not going to talk about that. I'm going to talk about facades, because I'm going to focus today on just one little element, and maybe at another time talk about other issues. This is not my first facade talk. This is actually my 76th facade talk. Try saying that fast. Why? Why am I talking about facades? I'm not talking about facades because of Grenfell. I've been talking about facades since La Crosse. And it's really interesting. When we had the fire at La Crosse, the MFB issued a report a few months later. And I read the report and I said to Red Fire engineers, I'm going to take 2 days and put together a white paper for internal use for the company for how to deal with facades. At the end of 2 weeks, my boss said, "Are you done with that 2-day paper yet?" And I said, "Well, I finished it the first day, and then I started to realize that the building codes seemed to say something different than what practitioners were actually doing. Not all practitioners, but many. So I started to call my friends. I don't know if I called Peter. Peter Johnson's up here. He's the one who first brought me to Australia back in '92. It's his fault that I'm here. But I started calling my friends, and I said, "What do you do about facades? What do you understand about the BCA?" And it took 2 weeks to put together a document that seemed to make sense, but was scary to me because it was different from what had been what I'll call often routine practice for 30 years. So we're going to talk about that today as well. So we're going to start by what is the problem. We're going to learn a little bit about history, and yes, I was a professor for 30 years, so I'm going to go back to ancient Rome. And I'm going to talk a little bit about the building code and deemed to satisfy versus performance solutions, and a look into how do we decide if our buildings are safe. So as with all my talks, I start with major facade fires, and now sadly, the first one, of course, is the recent one in London. I'm sure, unfortunately, there are way over 100 people who died. We'll never know everyone because so many were illegal immigrants. And even many of the survivors are afraid of coming forth and saying, yes, we survived the fire, because they're afraid of repercussions. They've been following Trump too long, I think. I know, I do have these bad jokes I throw in the middle of my talks because this is such a serious topic. It's really, it becomes very hard to talk about them. Until now, the big fire, of course, was just 2 years ago in Baku, where 15 died, 63 were injured, in a facade fire, or more importantly, in 2010 in Shanghai, when 58 people died and 70 were injured. We didn't learn our lessons. Facades have been a problem. Just the last year and a half, there have been 3 significant fires in the UAE. And of course, our fire here in Melbourne. At one point, we used to think it was a third world problem. In fact, on the day of the La Crosse fire, I had finished putting together this talk that I was giving that afternoon to Engineers Australia conference about sustainability in fire engineering, and one of the problems being, as we make our buildings more sustainable, more energy efficient, we create fire problems. And that was the thrust of my talk that afternoon. This fire is really interesting, one in Dubai, because it started in the lighting system that lit up the building at night. If I was in America, I would say, you know, they follow this British code. It's like the Australian electrical code, irrelevant to Americans. Our code is very different. It's actually worse, but don't tell anyone. This was scary to me here in Australia because the electrical system in Dubai and their code and the talent of the engineers and the builders are very similar to what we have here. Ashburn was another one of these really interesting events from a fire engineering viewpoint. Imagine a shared car park, a pedestal, with 7 towers. The fire started in one of those towers and then spread to 2 other towers. Here's a close example of another facade. See that? Bushfire ember attack. Facade ember attack. Wow. As fire safety engineers, when we start looking at, is our building too close to the neighbor, we do a radiation calculation. This isn't a radiation calculation. This is a flying ember. Big ember. We're not routinely looking at it, should we? Beijing, this was a hotel that was being changed from 4-star to 5-star. Absolutely amazing. For every floor of this tower, they had 50 workmen working simultaneously in the floor. Do the arithmetic, multiply by 30 or 40 floors. It was a tall building. How do you get everyone in to start work at the same time? In China, they're able to do things differently than we do, and they have different problems, but they had a facade fire. The U.S. has facade fires too. This one's Las Vegas. What's interesting about this one is, here's a firefighter. OH&S rules in Australia would not let a fiery get up on the roof and bend over with a nozzle to try to put out that fire. All right? Americans are a little crazy. By the way, guess what started that fire? Sign. The neon sign? No. They were, good idea, but no. They were welding gun emplacements. It is America. All right. What's a facade fire look like? We're going to see if, I don't know how to put sound on. Oops.
Sorry, I just put the...
Kate's the expert.
Sorry, and the expert forgot to put it on.
So this was in France, another one of those third world countries. Now there's a bit of a jump in the start. But look at the fire as it spreads up the facade of the building. Unfortunately, there was 1 fatality and 6 injuries in this building. If the wind had been blowing the other way, we probably wouldn't have had the fatality or probably most of the injuries. A lot of these facade fires are controlled by the wind, by the environment. They're outdoor fires. Imagine you're in one of those little red trucks and you're pulling up to this fire. And you say, okay, what do I do? It takes you, well, a minute, a floor as you get higher up in a building to climb up the stairs. You're wearing breathing apparatus and all this other equipment, and you want to fight the fire. How do you fight it from the inside of the building? You need to have a staging area. It needs to be near the fire because the air bottle you're wearing only lasts 20 minutes when you're breathing heavily. and then when you run out of air, you have to go down and get another bottle. In Grenfell, if you read some of the first account by the fireys, they talk about getting up to the 15th or 16th floor and running out of air, and then having to go back down to get another air bottle to go back up to the 15th floor. How are they supposed to get higher up and rescue people? And they said to themselves, do I keep going without oxygen and then have to be rescued myself, or do I just leave those people to themselves? Some fireys went up another 2 or 3 levels and then gave up. Can you blame them? Of course not. That's the challenge of fighting fires in these buildings. Our normal way of doing it, of fighting a fire, is setting up 1 or 2 floors below the fire floor. We can't do that with these facade fires. So this is Melbourne. So this is home. We don't have to go overseas. By the way, this is not our first facade fire. I found pictures of facade fires in the early 90s in Sydney. Bankstown. You remember the Bankstown fire of a few years ago where the 2 girls jumped? One died, one became a paraplegic. Do you know that last year they had a facade fire? Right? The front of their building was an aluminum composite panel. Right? It had another fire. Luckily, it was set back from the tower, so the fire didn't go anywhere. Right? We have facade fires right here in our backyard. By the way, my colleague, Blair Stratton, was taking the train into the city on the 25th of November because he was giving that talk with me at Engineers Australia, and I said to him, you know, when you're at Southern Cross, lean out the window and take a picture for me, please. So I could add this to my slides. This was a horrific fire in some ways, but not so bad because no one died. Some would argue that it shows how amazing our building regulations are. They're right on. The purpose is to save lives, and no one died, so the building regulations were fine. Or did we get lucky? We had so many challenges in this fire. There were 400, 500, we don't know how many people were in the building. Can you imagine a 2-bedroom apartment with 12 occupants? Can you imagine a 2-bedroom apartment with bunk beds where there's a time schedule on the bed where people are saying what shift they're going to sleep? Welcome to Melbourne. I hope none of you are living like that. Don't raise your hands if you are. The loss, 25 million plus. 122 firefighters involved. In a smaller city, can we put 122 firefighters trained for fighting high-rise fires together to deal with such a fire? The answer is probably no. The fire, as you know, was not far from here, down in Docklands. Great neighborhood, great location. The location's really important. The infrastructure there is relatively new. The water pressure is good. By the way, it was a nice building. It is a nice building because you can still live in it. You read some of the press reports and you hear some of the occupants who are in there now didn't even know there was a fire. The fireys know there was a fire. Look at all the fire trucks lined up. These fire trucks, of course, are lined up, and if there had been another major fire in the city, where would the fire trucks have come from? Well, the CFA would have come in and rescued us. Whoa. I won't go there. I like the CFA guys. Are they used to fighting high-rise fires? No. The brigade had its challenges dealing with the aftermath. And we're going to come back and look at these pictures because they tell a lot. Now, photograph on the right. Does that look like an excessive use of an apartment balcony? Don't answer that. If you come to my house, look at my balcony outside of my bedroom where the guests can't see, and guess what you'll see? You see my laundry, all right? You see other things that are there. That's because I live by myself in a 2-bedroom apartment, so it's overcrowding. No, it's because I'm a bit of a slob, all right? Is this an unreasonable use of a balcony in Melbourne? I don't think so. So is this overcrowding? Probably not. Picture on the left, We'll come back and look at that some more, but that's, the fire started near that air conditioning unit. After the fire, they took the pieces of aluminum pretty stuff. I hope no one from the architectural firms here, but if it is, I'm insulting you, I apologize. The stuff that makes buildings pretty is not of great interest to me as an engineer, other than the engineering to keep it up and keep it safe. They don't have a glass balustrade problem on the left. They have a plywood balustrade, which is sort of interesting. Is that livable? Well, you can't fall out, so I guess that's all right. Should we put people behind plywood balustrades? Why not? So the fire actually went up, see where that red oval is? The fire went up sort of in that area. That's why you see all the plywood balustrades. That red arrow is pointing to the corner of the aluminum composite panel facade where the fire was able to go from its origin all the way up to the top of the roof. You get a better handle of that, and you get an idea of the size of the bedrooms. Fairly large for Melbourne these days. That was funny. No? All right. This is really interesting. So the kitchen and bathroom exhausts vent through a grill on the balcony. That's that yellow thing. The green lines are the ductwork, which is really just a plastic duct. And it's not sitting in your living room, it's sitting above the ceiling. The building is sprinkled. Where are the sprinklers? The sprinklers are below the ceiling. The combustible ductwork is above the ceiling, between the ceiling and the floor slab, so in this interstitial space. But that's okay, because a fire in the living area would have to bypass the sprinkler system to get up into that space, unless the fire started in the balcony and then entered through this grill. Oh, I hadn't thought about it. I won't get into that grill unless there's a fire source out there, such as a combustible facade. And if it gets into that space, there's no sprinklers. Well, that's all right. There's nothing else that's really important except those red things, which are the cables for the EWIS system, the speakers that let you know there's a fire. So all of a sudden, we have these unintended consequences of our designs. We've got a combustible facade. A fire out there can actually destroy the alarm system or the speakers. Who would have put the two together? In my building, which is also in Melbourne, the same fire engineers said, look, we're not worried about a fire getting into that space, and so we don't have to have any fire resistance between one apartment and the next because it's sprinkled and there's a ceiling and we can't get above the sprinklers with a fire. So we'll just put a little smoke separations. We won't actually seal the penetrations. It's not a problem in Melbourne. I think La Crosse says it is a problem. Interesting. The building was sprinklered, and there were sprinklers in the important rooms. So if you think about a fire that started in this balcony, all right, if it burns through the wall behind the air conditioning unit, you've got a sprinkler head to control it, which is great. If it breaks through the glass, you've got a sprinkler head here to control it, and that's great too. We'll come back to the sprinklers. One of the things you read in the press is that our buildings in Australia, we can't have the London fire because we have sprinklers everywhere. Well, if the building's over 25 meters, we might have sprinklers. Not all buildings over 25 meters do, but most of them. So how did the fire start? Well, without mentioning names, the builder says it's the guy who started the fire that caused all the problem. At least that's what the newspaper says. an occupant was sitting out on the balcony smoking. And he put his cigarette out in an ashtray. The ashtray happened to have been made of a yogurt container. He'd been using that yogurt container all his life. If you know anyone who smokes or have ever smoked yourself, have you ever seen anyone put a cigarette out in a plastic container? Come on, raise your hand. Thank you. Lots of hands go up. So is this an unusual thing to use for an ashtray? No. Is this something we should expect? Of course. This is how people live. We should be designing how people live, not how we think they should live. All right. Fire started. The ashtray, the yogurt container melted. The contents spilled. A little bit of a flame ignited some papers. Oh, terrible. He's a slob. He left paper everywhere. You've never left a piece of paper on your balcony, have you? Well, I have. I'm a slob. I told you that already. The fire got behind the air conditioner, ignited the cladding behind the air conditioner, and that's all it took. We'll come back to that in a second. So this is what the apartment sort of looked like. So here's the air conditioner. The fire got behind there. Not bad looking apartments. Not bad until you have the fire. All right. You can see through into that bedroom. So there was cladding, some insulation, plasterboard, and fire burned through that, got into the bedroom, the sprinkler stopped the fire. All's good. Except the fire got into this cladding and went right up to the top of the building. Now, I said all's good. You probably can't read this too well, but this shows before the fire, they were getting $545,000 for an apartment. After the fire, well, what happened to the value? Rental apartments went from $500 up until down to $480. They used to be able to rent in 20 days. It then took 66 days to rent. Big change. Is this proof of a problem? No. I just grabbed some numbers off the internet. Don't believe my numbers. All right. Do you expect values to decrease if people know there's a fire that's been in your building and it's in the paper? Absolutely. If they know that your building has a non-compliant facade, do you think you can sell your apartment for as much money as before they knew it was non-compliant? I can tell you from my building, that's been exactly what has occurred. What is the cost? For La Crosse, $6.5 million of fire damage, including $700,000 of water damage. So those bloody sprinklers put water everywhere. 26 sprinkler heads operated. How many heads do we expect to operate before we normally run out of water? 8 to 10, even in a combined system. Wow, how come they still worked? Well, they worked because the fire was at 2 in the morning. No one in Docklands is using water at 2 in the morning. Guess what time people start using water? Around 7 a.m. when they get up. We got lucky. The fire was at the right time, so there was ample water in the neighborhood. What are the other costs? $1 million in lost rent, cost of emergency accommodation, $8.5 million in cladding costs. Insurance, all right, has gone up an increase of $130,000. In my building, which has 324 apartments, the Owners Corporation's insurance this year is going from $35,000 to $70,000 because of non-compliant cladding. And we hear that time after time after time. All right. So this is a Class 2 occupancy. We need Type A construction to meet the deemed to satisfy requirements. And I'm just going to take 1 second to remind you there are 2 ways of meeting the performance requirements of our building regulations. One is through a performance solution, and the other is through a deemed to satisfy solution. And the deemed to satisfy solution is the only one that tells you how to build things. The performance solution is something a fire engineer comes along with, and he says, well, in order to meet the performance requirements and expectations of society, expectations of the building code, here's how you can do it. All right? And I'll come back to that again in a minute. All right, you all want to know about Grenfell Tower. As I promised you, I'm not going to tell you anything you can't find online. I wish I had more information. I don't at the moment. Flying debris. There's the Ember attack going on. Luckily, the building was far enough away from others not to start another fire. Spalled concrete. This building was built in 74. In 68, Rowan Point, there was a fire in Council Flats, and Rowan Point there was a small gas explosion, and it wiped out a whole side of the building. Not quite the whole side, but much of it. As a result, the British changed their building code to require much higher fire resistance, and more importantly, to tie their building tightly together. If this had happened in a building designed before 68, before Rowan Point, I think we would have had at least some partial collapse. But because it was designed afterwards, the building was well tied together. Do we do that in Australia? No. We do not build buildings structurally the same as they do in the UK, with a few exceptions, all right? There are engineering firms who particularly practice internationally. Arabs, for example, is one, and their designs will really look at the performance requirements, and they'll do what's needed. But all too often here, we do the minimum that's needed, what our building regulations call for. Was there anything else unique about these fires? No. These are the lift doors. Notice they got hot, they warped. When they warp, guess what? Smoke can migrate up the building through the warped doors. I want to show you some of the cladding, and we'll come back to that. But basically, you had this concrete building, and they put a decorative cladding on it. And behind the decorative cladding was basically a passageway for heat and smoke and fire to spread. There are two absolutely great articles in the New York Times. So just look up Grenfell Tower, June 24th. That's all you have to remember. Or you can take a picture like he did. Nate, I don't know. Bloody Americans. Thank you. These are really, really good articles. They're written by the same reporter who wrote most of the articles in the New York Times after 9/11. And it's top-notch research, and I highly recommend them. One of the things they put together were some graphics of the cladding, all right? Basically, we had a concrete wall, an insulating panel, a 15 mil gap, 2 inches if you insist, and an aluminum composite panel. And that's what the facade looked like. And there was, from a practical viewpoint, based on what we saw, I saw very little evidence of successful fire stopping within that space. Once a fire seemed to get into that space, it just spread through the building, both vertically and horizontally. Now, the details of fire stopping, the details of what existed or didn't exist, we're all guessing at right now. I can only tell you that whatever they tried to do, if anything, didn't work. I can only talk about the outcome, but I can't tell you why. The other thing that you'll read is about gas explosions and other problems in the building, right? We have no evidence of that. We have the tenants who said there was gas pipe exposed in the stairway, but we don't actually know if that was involved. Explosions could have been just from a paint can that someone had in a bedroom, right? Well, you keep it in your bedroom when you go spray painting walls and things like that. Bad joke too, okay. Look, the fire we do know started in a refrigerator. We have an eyewitness account of that. I thought it was interesting. This is one of the kitchens, and they all have different layouts. But if you look at this kitchen, where would you put the fridge? Right? Well, you'd probably put it up here. Doesn't look like there's room anywhere else. If you put the fridge there, it's near the window. So if you have a fire in the fridge, you don't actually need to involve anything else to perhaps ignite the cladding right outside that window. There's also some evidence that I've read that there was some ventilation openings between the apartments and the cladding. But I don't know any of that detail yet. But as you read accounts of what people think happened, wait until you actually know how the building was built. Wait until the investigation was done, because these details we really just don't know. It's all speculation. What I do know is that the British have said, oh my God, we've got a huge problem. We're going to look at our public housing stock, and we're going to make sure they're okay. So they decided to do an audit of 600 buildings, and it's going to be thousands of buildings now as they continue to look. If you read in the press, you'll see none of the buildings have passed. Passed what? Well, they've done a combustibility test, and we'll talk about that in a minute. The Australian version is AS 1530 Part 1. It's a little bit different from the British, but close enough. We know that Grenfell used an aluminum composite panel with a polyethylene core, and behind it was what's called a PIR foam insulation, a Celotech RS5000. Those are facts. That's about all we know right now. We do know they did not use an aluminum composite panel that was fire retardant. If they had, would the outcome have been different? So I've been trying to find what's the relationship between having this aluminum composite panel and insulation and a gap and a fire between them. And I actually don't know how that FR product will behave. I do know how the polyethylene product behaves. It doesn't do well. I do know that the polyisocyanuric foam panel, which is that Celotech panel, when it's next to a high radiant flux like you get from the aluminum composite panel, I do know the PIR panel doesn't do well. I don't know what happens when you start changing things around. We don't have that information yet. Anyway, the important thing is the British have said, if we see anything combustible, we're going to panic and take people out of the building. How the product is used doesn't seem to be part of the initial audit, although I understand they're finally starting to hire some real engineers, fire safety engineers, who are starting to look and say, yeah, well, maybe this is okay and maybe this isn't. So these are just some pictures of buildings with aluminum composite panels. Start a fire down here, maybe a car crashes in, and you have the fire on the roof. It takes about a minute to go up your floor. This was interesting. So they found some panel, they removed it off the top 2 levels and left it on the bottom level. I don't know, I probably would have taken off the bottom 2 levels and left it on the top. I'm a little confused. Pretty pictures. All right. Can I show you pictures of buildings that look like this in Melbourne? Could it happen here? This is a quote from the CEO for the Australasian Fire Authorities Council. There's a national requirement of the National Construction Code for all buildings above 25 meters, not only the height that can be accessed by fire service ladders, to be serviced with sprinkler systems, something that was missing at Grenfell Tower in London. Australian high-rise buildings have a requirement for 2 fire escape staircases, alarms and detectors throughout, and for occupants to conduct regular fire drills. So, if you live in an apartment, how many of you have ever done a fire drill? Thank you. How many of you have a friend or live in an apartment with a single stair? I do. So a few hands, don't be shy, you can raise your hands. So what's being talked about here is the deemed to satisfy provision in our building code, not the performance requirement, not the performance solution. So our life in Australia is very complicated. This is why I couldn't put my white paper together in 2 days and it took 2 weeks. Right? Because we get a little bit confused about what is deemed to satisfy, the old prescriptive part of our building regulations, and what is a performance design. So in my view, could Grenfell happen? I think it could. We had a lot of sprinkler heads operate. Imagine if it had been in a different part of the city where the water supply wasn't as strong. Once the sprinklers were overrun, there's nothing to stop the fires from spreading into the building. The fire happened at the right time of night. And you saw from the pictures I showed you of all the fire trucks lined up on the roadway, there was elevated roadways. They got to jump on the height of the building. Are we doing anything? Okay. We did a VBA audit of 170 buildings in the CBD. A little over half were non-compliant. Wow. Are these unsafe? I don't know. They don't meet the deemed to satisfy provision of the building code. Does that mean they're unsafe? No. We have to ask, do they meet the performance requirements? I'm sorry, I couldn't resist adding the CFMEU to the slide. Why would I do this? Because, as you read in yesterday's paper, they feel that our buildings may be unsafe, the ones they are building, so much so that they've told their guys to keep an eye out for unsafe cladding. I'm sorry, the world's upside down when we're depending on union workers to inspect our buildings and make sure they're safe. Or maybe we're in a wonderful place where we're all coming together to work together on this, which is the way I'd rather look at it. But wow, have we lost so much confidence in our systems? Maybe we have. Well, life doesn't stop with the CFMEU. There's an urgent probe just been announced where we have a liberal former premier and a Labor deputy premier coming together. Wow, this is amazing. Never would happen in America, that's for sure. To work together on this problem. We have the current chair of ABCB, and we have an architect who are also politicians who are recognizing we've got to do something and do it right away. And we have a Minister of Planning who's saying there's nothing more important than public safety and for people to have confidence that Victoria's buildings are constructed properly. Well, I can tell you they're not all constructed properly, but many are. But we don't actually care about the ones that are right. We care about the ones that aren't, and how do we identify them? And that's sort of our challenge, isn't it? Because that goes back to why we're all sitting here, the lessons learned from London. Let me go back to lacrosse for a second. The first thing that the municipal building surveyor required was that the essential safety measures be reinstated. So remember I said that the alarm system, the speaker wire was damaged, so that had to be fixed. They also said no more overcrowding allowed. Although in the paper I just read there's some overcrowding, but I don't even know how we control that. Limited storage on balconies, but if you go by the building, you'll see people don't seem to be paying attention to that. The MFB are now sending 2 fire trucks in case of a false alarm. And because of all these things, we're now reoccupied lacrosse. Have we changed anything fundamental about the building? So the question we have to ask, is it enough? And I just leave that as a question. I might have an opinion. So that's one way of responding to a fire. What does an engineer, a fire safety engineering do? A fire engineer do? We know, as fire engineers, that there's no such thing as absolute safety. And after an event, politicians and the public thinks that's what they want. Absolute safety. We want to be 100% safe. We want nothing to happen, irrespective of the cost, until they see how much the cost is. We as engineers can apply a risk-based approach, but what level of risk is acceptable? The same level of risk as when you go out and play golf and get hit by lightning. That's a given level of risk. The risk of stepping outside and being run over by a tram, that's another level. What's an acceptable level of risk living in your own home? It's not for us as engineers to decide. It's really for politicians, but they need to have, thank you so much, they need to have some information so they can help define what an appropriate level of risk is. So we as engineers may be able to assess or determine the probability of an event or the consequence, but who's willing to pay for it? Who's willing to pay for our analysis? If we were designing a nuclear power plant or doing a chemical plant, we get paid to do that. Do you think we actually get paid to do this for an apartment building in Melbourne? Absolutely not. Could we do it if you gave us enough money? Sure. Is that something we should be doing? Maybe. It's also not our role to trade off one risk for another. A friend of mine said, we can make hospitals a lot safer, but if we do that, maybe they won't have enough money to buy the latest CAT scan machine or the latest robot for operations. And think of all the lives they could save with that versus what we put into fire safety in the building. Well, again, that's not for us to make that decision. That's something where we need politicians and who can actually come together with this. This is where ABCB, as a governmental agency, should be providing information. All right. So what are our facade safety regulations, and how do they address La Crosse and Grenfell? And why have we been using non-compliant material in designs? I just want to make it clear that the problem is not simply due to cheap Chinese imports. You can argue that I'm wearing a cheap Chinese import. I paid a lot for my Apple Watch, right? So it's not just because it's from China. It's not due to builders and developers just trying to save money. I think a lot of it is a lack of understanding of the risk of aluminum composite panels. And there are lots of them, all right? But if you take a panel like used in Grenfell with a polyethylene core and compare it to a panel like a Lucabest that we had in the La Crosse Tower, it doesn't matter the brand name, it doesn't matter where the panel was made, it doesn't matter where the polyethylene was made, polyethylene just knows it likes to burn. Right? So when you have two things that are chemically the same, they're going to burn and behave the same way. So what is an aluminum composite panel? It's a bonded laminated material. The building code refers to the layers as laminates. Our building code is unique in that extent. There are lots of things that they're typically 3 layers, but there's paint and there are other finishes we see on panels. But we talk about the 3 major layers, the 2 sheets of aluminum and the center core, because those are the primary components. And from a fire viewpoint, what do you think is going to burn more, a thick core of polyethylene or a little bit of paint? Obviously, it's the polyethylene. So we ignore some of the other products. The stuff is lightweight, has beautiful skin properties, works really well to keep the weather out. It's easy to install, it's pretty, it's attractive, architects love it. So now I'm going to regress and talk a little bit about our building regulations and the deemed to satisfy requirements for paneling. The building code looks at 2 situations. One is where the cladding is part of the external wall, and one is where the cladding is an attachment. If it's part of an external wall and it's type A construction, then it must be non-combustible, as defined by the building code. If it's an attachment, well, maybe it can burn a little bit, and we'll talk about what that means. So when we look at a building code, the first thing we do is we read the definitions in the code. If something is not defined in the building code, then there have been 2 court rulings, one here in Victoria and one in New South Wales, which says you go to the dictionary. Now, you're not allowed to go to your favorite architect's dictionary. Do I have any architects here? All right, don't mean to pick too much on you. You're not allowed that. Okay, good. You're not allowed to go to the American Webster's Dictionary. You're not allowed to go to the Oxford English Dictionary. You go to our dictionary, Macquarie. And Macquarie says that a wall, and it gives a definition, goes on for the 3rd definition, anything which resembles or suggests a wall. I love dictionaries, don't you? The ABCB have defined an external wall as a wall that's not a common wall. That's a wall between 2 units, for example. And the integral components are, now listen to this carefully, external cladding, framing, spandrels, insulation, and internal lining. So basically, you start on the outside of the wall, and you work your way in until you get to the inner surface, and that's the wall. Does this sound shocking or surprising to you? I hope not. There's actually an ABCB policy document you can get on the website under education. Just look up external walls and cladding. What's an attachment? The dictionary definition that applies is an adjunct or supplementary device. Now remember that definition, adjunct or supplementary. That means you can take it off. That means it's not critical, right? That's what those words mean. Now why do we care? All right, so here I get put on my professor hat. Although it's been a few years since, it's been 10 years since I was a professor. It's kind of exciting. We have a history of providing non-combustible exterior walls with a fire resistance level. Now, you can't quite read that document, but it's the grading of buildings that was published in 1948 in London as a response to the fires that occurred during the Blitz. So what happened during the Blitz? It wasn't just the German bombs that caused the fires, but it was combustible facades, buildings too close to each other, easy fire spread from building to building. All right? So we put together a building code in 1948 to keep our cities from burning down and prevent fire spread via the facade. So now we're going to turn back the clock. I like this. Now, many of you know about the Code of Hammurabi, and that was the one where if you built a bridge, right, we made sure the bridge worked because you put the builder and his family under the bridge and you drove over the bridge to see what would happen. Don't get ideas with your local builder, please. The first modern code was written in the year 27 as a response to a collapse of a Colosseum. And that Colosseum, there were somewhere around 50,000 people killed or injured. So the Romans said, enough of this stuff. We better have a building code that will protect us from structural failures. So to the best of my knowledge, this is the first modern structural code. In the year 64, Rome burned down. This is the fire where the Emperor Nero was there fiddling as Rome burned. Okay. Why did it burn down? Combustible facades, buildings too close to each other, lack of fire separation from the boundary in essence, lack of services for the fire brigade. So in the year 66, the Romans published an addendum to their building code, which added fire provisions. So the building code by then consisted primarily of a structural code and a fire code. Pretty cool. We, of course, learned our lesson. And 1,600 years later, there was a great fire in London, and why did London burn down? Buildings too close to each other, combustible facades, lack of access for the fire brigade. Oops. I wonder why they wrote their own code. All they had to do was translate the Roman code from Latin into English. The problem hadn't changed in 1,600 years. We just forgot the problem. 1871 in Chicago, Can you imagine 17,000 buildings were destroyed? This was the fire started by Mrs. O'Leary's cow. She kicked a lantern over. And why did the city burn down? Combustible facades, buildings too close to each other, lack of facilities for the fire. Am I starting to sound boring? I apologize. The bottom line is that throughout modern history, the adoption of updated building codes is a response to a fire rather than in anticipation. There are a few examples, a few minor changes to building codes, but the big changes happen when we have a fire. Did they happen because of lacrosse? No. Are they happening because of Grenfell? Yes. Sadly, you have to have a shock to get changes. Now going back to our code, deemed to satisfy. If the cladding is part of the external wall, then one of the first things I ask as a fire engineer, I wonder if I need an FRL. So I go to the building code, and I notice that there's a table which says that if the wall is load-bearing, then I always need an FRL. That's what the 90, 60, 30 column means. And if the wall is not load-bearing, and it's more than 3 meters from a fire source feature, like the boundary, then I don't need an FRL. Oh, cool. I wonder what load-bearing means. Now, you might say to me, Jonathan, don't you have 2 degrees in structural engineering? How come you don't know what load-bearing means? I said, because I didn't write the BCA. And I'm not, as a structural engineer, I'm not allowed to guess what a word means if it's defined in the building code. I need to go to the building code. The BCA defines load-bearing as means intended to resist vertical forces additional to those due to its own weight. So if I have a wall, and I have cladding that is part of the wall, then the wall doesn't necessarily have to be load-bearing. If I have a wall, and the cladding is an attachment, it's separate from that wall, and that wall is carrying it, guess what? The wall becomes load-bearing, as defined by the BCA. Wow, this is where people have gotten confused. Another way of deciding if the cladding is part of a wall or an attachment is what happens if I take the cladding off? Remember, an attachment, as defined, is a supplementary or adjunct device. So if I take it off, I should still have a wall. It might be ugly, might be concrete, yuck. Or it might be something else that looks terrible. But does it still have the characteristics of a wall? Does it keep the weather out? Very simple question. Does it protect the building from a nearby fire? All these things that walls do. All right. So I've been talking about combustible and non-combustible. How do I know if something burns or not? Well, I'm not allowed to guess. I'm not allowed to use my own backyard experiment. I go to the building code. All right? So if I'm starting to sound boring again, I apologize. It's all in the code. You have to read what the code says, and you have to look at the history and the background of the code so you can understand it. The building code says it's combustible if AS 1530 Part 1, 1994 version, when you test it to that standard, if it's deemed combustible. Basically what you do is you take a sample of half the size of this glass, you put it into a furnace at 750 degrees, you look to see if you have any flaming that lasts for more than 10 seconds, you look to see if the furnace temperature increases more than 50 degrees or if the specimen temperature increases more than 50 degrees. If it does any of those things, then it's combustible in accordance with the test. If it doesn't do those things, it's non-combustible by definition. Oh, what about cladding? The test standard actually says the test method is not applicable to products which are coated, faced, or laminated. So you can't use AS 1530 Part 1 directly on a piece of aluminum composite panel. Instead, the standard goes on and says, in such cases, tests may be carried out separately on the individual materials from which the product is formed. So you don't take the whole piece of ACP and put it into the furnace. What you do is you take it apart, and you test the 2 sheets of aluminum, and you test the center core. So here's an example of how you might take a sheet apart. All right. Now, the building code goes on and says, in clause C 1.12f, you check to see if the layers are non-combustible. You check that each adhesive layer doesn't exceed 1 millimeter. You're actually not testing the adhesive. So what the BCA says is just make sure you don't have a lot of glue there. You go on and make sure that the total thickness of all the adhesive layers is less than 2 millimeters. You then do a spread of flame test and a smoke develop test. And if it meets all of these requirements, it's deemed non-combustible in terms of how the building code views it. So the building code says, if all of this is true, then you can use the product wherever you can use a non-combustible product. So let me give you an example. Here is a piece of aluminum composite panel with a hole drilled in it. What do you see coming out of the hole? A power cable. Now, I, of course, had an electrician come and unscrew the light that was on the other side of this cable. I have to follow the law very carefully. This was on my balcony. It is on my balcony. Now, what do I see? I see an almost black center core. If it's polyethylene, well, if it's black, it's always polyethylene. If the core is white or off-white, it might be polyethylene. It might be a fire-retardant material with a mineral fiber, with inert filler. But if it's black, it's always polyethylene. So this was an aluminum composite panel with a polyethylene core, and what has the wonderful builder done? He's drilled a hole to expose the fuel, the polyethylene. And what else has he done? He's put a heat source, called an electric light, on it. So if I have a failure in my light, it'll be easy to ignite the panel. It was so nice of him to do that. By the way, just a meter above this is the vent that goes into the interstitial space above my ceiling. So that a failure of this light can result in the sounders in my apartment not working and telling me that there's a fire. And smoke and fire spreading into the apartment above, except I'm in the penthouse, so there's no one above me. Thank God. Wow. Are there other buildings in Melbourne like this? Of course there are. Now, this was sort of interesting. This panel, there was an air gap, and then behind it was a James Hardie Exotech cement sheet, which is deemed non-combustible according to BCA specification C 1.10. By the way, by way of disclaimer, James Hardie is one of my clients, so I like their products, and I need to tell you that. Then there's some glass wool, and then 13 mil plasterboard. The James Hardie system has excellent resistance to water penetration, high wind loads, and is suitable for exposed applications. So think about that. If I remove the ACP, guess what I'm looking at? A wall. Oh, wait a minute. If this James Hardie system is supported off of the rest of the wall has to be load-bearing and have an FRL. Does it have an FRL? All right. Well, the answer is no. But it gets more complicated than that. The fire engineer omitted sprinklers from my balcony. And in his wisdom, he did so. He required what? He required that no combustible materials be used in the design of the balcony or the facade. It's in his fire engineering report. Do you think the facade engineer was given the fire engineer's report? course not. Why would he? Who would connect the two together? The architect should have. The builder should have. But it's not something that's normally done. Anyway, this wasn't compliant. Why is that flashing? Trying to give me a message. Very strange. So another part of thank you. Another part of the building has a wall where there's a aluminum composite panel, then a PIR insulation. Happens to be a panel, all right, with so it's not as bad as Grenfell. An air gap. Doesn't this sound just like Grenfell? Very close. This is in my apartment building. And it comes all the way to ground level where a car, for example, could hit it, start a fire. A skip could be down there, start a fire. Lots of ways of starting fires. And they would be up in my apartment within 5 minutes. But there's a glass wool insulation. That'll melt, get out of the way. But there are 2 layers of 16 mil plasterboard. That's cool then. What do you find in plasterboard? You find PowerPoints. I'm sure there's a PowerPoint. There's a PowerPoint there. What's behind the PowerPoint? A fire-rated box, right? Not in my apartment. The fire engineer said, don't worry, non-combustible external walls, there's no way a fire is going to come in. His design didn't include the fact that they were putting all this fire this risky material in my building. By the way, I did spend $1,500 to put fire boxes behind all my PowerPoints. And I recommended my neighbors do the same. All right, let's move on. Let's say the facade is an attachment. So a combustible material may be used as a finish or a lining to a wall or roof or in a sign, sunscreen, a blind, awning, or other attachment to a building, supplementary or adjunct device, which has the required FRL, if, and then there are a bunch of requirements. Let me just go back to lacrosse. Notice that if you take, this is sort of the remains of the ACP. Behind this is the plasterboard. So if I remove the ACP, I could actually see into the back of the plasterboard. Was this an attachment or part of the external wall at lacrosse? It's part of the wall, no question about it. All right, so moving on. Was this combustible? Probably. I doubt it passed 1530 Part 1. Just a side note. All right, so there are 3 provisions. The first is the material exempt under C1.10 or comply with specification C1.10? Just get a certificate, look it up, see what it says. The manufacturer should have that. Specification C1.10 is really cool. It exempts things like plaster, cement render, concrete, plasterboard. Plasterboard burns, of course. It's got paper on it. Is the paper bad? Yeah. Is it very bad? Nah. So the building code says it's only a little bad, you're allowed to have it. The last item, paint. You're allowed to have a little paint. 30 layers of paint, well, that's not what the code is imagining. Timber window framing. I was giving this talk to some architects, and they said, look, Jonathan, here's a wall all out of timber, and there's a window in it. Isn't that wall framing the window? That's not timber window framing. But that's a literal interpretation of the building code without showing any understanding of what's meant. We're trying to do what? Keep our cities from burning down. If we were in another state, then we would also have any other material that does not significantly increase the hazards of fire. This is Victoria, and that provision of the building code has been removed. I don't know why they don't trust us. The next item there's not enough of you are smiling. Come on, I have a bit of a sense of humor. The second, so that's the first, is it combustible or not? The second is you're not allowed to use an attachment if it will make an exit unusable in case of a fire. So if I have an attachment over here, and I have an exit over there, do you think that a fire over here is going to make that exit over there unusable? Probably not. But if the attachment moves closer, at some point it will make that exit unusable, particularly, let's say, if it's over the exit. How close is too close? Perhaps you need to have an engineer evaluate this. But this is weird. This is deemed to satisfy, and building surveyors do deem to satisfy. They don't go to engineers for an opinion usually. Well, maybe they need to. The third and final requirement for an attachment is that it not constitute an undue risk of fire spread via the facade. Think of Grenfell. Before they put the facade on, they had a building that had been in existence for 30 years, 35 years. And that building, basically, the wall, that was a concrete wall. So what was the cladding that burned? It was an attachment from a BCA perspective. But would it be allowed under deemed to satisfy? No, there was an undue risk of fire spread, as we saw, right? How do you determine that? Well, you have to know something about fire spread properties and fire scenarios, and this requires a fire engineering, an engineering evaluation. Well, can only an engineer evaluate fire scenarios, fire spread, and radiant heat flux? I'd ask the architect, but I don't want to ask him if he can do radiant heat flux calculations. No, he said no. Good, thank you. Gave the right answer. Yeah. All right. The point is that this is one of those weird, strange provisions in the building code that requires an engineer. All right, so that's the deemed to satisfy world. And my last 20 minutes, I'm going to talk about the fun world, the non-deemed to satisfy. So there are basically 5 provisions in the building code. You can do an alternative solution, also called a performance solution by a fire safety engineer. You can have a certificate of conformity, such as a code mark. You can have a report from a registered testing authority. You can have a certificate from a professional engineer, and there's some other forms of compliance. I'm going to talk about code mark very, very briefly. This is where you have a third party that evaluates and certifies products. Not for your building, but general certification. The ABCB has a register of these certified products, but they don't check to see if any of the products actually work as certified. What they do is make sure that the companies writing these certificates are trusted. There may be certain restrictions. It's really interesting because the code mark is sort of a universal opinion written for a particular product that can be used really for almost any building. It's viewed by many as part of deemed to satisfy, but it's not. It's actually a separate item in the building code. The trick with code mark is that products must be exactly the same as described. They must be installed exactly as specified, and every limitation in the code mark certificate has to be met. Right? I was talking to some architects the other day, and they said, we've never done that. We've always deviated a little. I said, well, then you voided all your code marks. Oh, we didn't realize that. Now, in general, the code marks are for aluminum composite panel are limited to non-PE cores. And up until Monday of a week ago, they were always fine, or was it? Because of Grenfell, there's now a new restriction. CertMark, on their website, has 2 advisory notes that came about as a result of Grenfell. And you can't read any of that, but basically what you have is the use and then where their code mark certificate can be used. But here is the most important restriction that we did not have until a week ago. This certificate, this code mark certificate, relates only to the subject wall elements reaction to fire. No evaluation has been made of any other wall system elements. So what they have done is they've only looked at one item, and they haven't looked at the whole wall, what happens when you put different things together. A review of the proposed wall system in its entirety to verify its compliance to relevant fire safety clauses of the building code should be undertaken by an appropriately qualified fire safety engineer. Wow. So last week they said, we've been issuing these certificates for years, and it never occurred to us that someone else could issue another certificate and you could put the two together and end up with an unsafe building. Wow. None of us had thought of that until Grenfell. Well, okay, moving right along. Everyone got very quiet. There are a couple of other resources. The VBA has an industry alert. CSIRO has a guideline that they're updating. So I now want to take the last 15 minutes and talk about performance solutions. This is where I, as a fire safety engineer, have fun. It's where I make my living. When I develop a performance solution or an alternative solution, I start by evaluating the hazard, and then I evaluate the expected performance of whatever it is I'm looking at, whether it's an egress system or facade. If it's facade, for me to do this evaluation, I need large-scale facade test performance data. Small-scale testing is not enough. What am I telling you? If you want me to check if it's going to work, you're going to have to give me information which will have cost you money. Sorry. What do I mean by large-scale tests? So ISO has a sort of the granddaddy of tests, ISO 13785. By the way, you need to be very careful. There's a part 1 and a part 2. Part 1 is a small-scale screening test. So if you pass part 1, you might pass part 2. If you fail part 1, you will not pass part 2, okay? One of my clients came to me and said, I've got an ISO 13785 certificate for this cladding. All right, can I use it? And I looked and it said part 1. I said, well, where's the part 2 certificate? Checked with the manual. Oh, we don't have one. Well, why didn't they? All right. So that's actually only a small-scale test that they passed. They didn't pass what I really needed to know if the product would work. There is a British standard, BS 8414. In this case, though, for the standard part 1 and part 2 is for different substrates. This is a very important test because it's sort of the basis of the Australian standard 5113. We'll talk about that in just a second. There's an American test. It's been around for 20 years. But unlike the British test or the ISO test, it doesn't have a wing wall. It's just a flat surface. So if your facade is flat, it's just a flat surface, single plane, it works great. That's why they haven't had a lot of facade fires in America. But if you have a complex, modern facade, really cool things that facade engineers are developing these days that make buildings attractive, that test is not enough. There's a Swedish test. The owner of my company is Swedish. I had to put that in. Then I still don't get smiles and laughs out of you. God. Then there is an insurance company test. Now this is really interesting. I'm going to just talk about the 50-foot corner test. Please bear with the American units. They take two 50 by 50 walls, put them together and form a corner and put a roof over it. Then they light this huge fire in the middle of the corner, and they see if it reaches the ceiling, 50 feet up. And if it doesn't, then it's passed this test. Now it's an insurance company. Guess what? The other tests are really looking at building safety and people safety, etc. The insurance test is looking at property protection. Guess what's the more severe test? The insurance test. So if you actually get something that meets the FM global standard, it's probably a better product from a fire viewpoint than something that meets one of these other test standards, even though it's talking about feet instead of meters. All right, here's the British test. Basically, you build a wall with a corner. This is 2 meters. This is 6 meters high or higher. So if you The test apparatus has been used for quite a few years in the UK. It is available here in Australia. Exova is the only lab that can do these tests at the moment. CSA down in Dandenong, they do it outside. They wait for a day when it's not windy and not raining. I don't know when they find that in Melbourne, but that's all right. CSIRO will be building such an apparatus, but they have to do pollution controls. They have some limitations on what they can do. It's a big fire, and you basically look and see what happens. The fire is a wood crib, 3 megawatt fire where you get a heat flux of 75 kilowatts per square meter. That's a lot of heat, a meter above the window. And you let it burn for 30 minutes. And you look to see how far is the flame gone, has the facade detached or collapsed. Part 2 is where you do a curtain wall, and you look to see if the fire's gotten behind the wall. So we do have an Australian standard. It's very similar, a little bit different. We put the thermocouples somewhere else. Why would we do that? We're Australians, come on. Yeah, exactly. And in fact, the British do have it wrong because they don't follow the ISO procedures where we do. So, there's also another difference in that the British test, you report on whether bits of the facade detach or fall off. In the Australian test, at the end of the test, you sweep up all the debris and you weigh it. And if it weighs more than 2.5 kilograms, you say, all right, it doesn't pass that criteria. The concern we have is the flying ember attack. It's actually debris falling on firefighters. It makes sense. Well, it makes sense if it's a solid chunk. Does it make sense if it's all the debris in the debris field? Maybe we need to fix it a little bit, but that's okay. Until 2019, the test, because it's not in the BCA, can really only be used by a fire safety engineer to support an alternative solution. It's not something that you could say, all right, I have gone ahead and had this test conducted, and now I can use my product. No, it can only be used by a fire engineer. In 2019, I expect that we will either see it in the building code or it will be referred to in the building code as a verification method or something like that. So stay tuned. More and more products are being tested to 5113. In the interim, until they are done, fire engineers have to use international test data. I can use the American test, for example, if my facade is boring, if it's flat. But if it's interesting, I probably need British test. The key to all of this is I need large-scale behavior and not traditional pass-fail, small-scale tests, and never just AS1530 Part 3. This is a Australian-developed test, the standard, which actually is for ranking of materials, but doesn't tell you anything about how they really behave in a fire. So you can't take test data and say, based on those numbers, I can predict how something will burn in a room. You can see if something's worse than something else, so you can rank it, but you can't actually predict large-scale behavior. The key is performance. That's what our regulations are all about. So, facade fire safety design can meet the performance requirements. We don't always have to comply with the BCA's deemed to satisfy requirements as long as we meet performance. We haven't always done it, and not all compliant designs are unsafe. They might need to be evaluated by a fire safety engineer. Fire safety engineers have the tools and knowledge to ensure that building designs can achieve an appropriate level of fire safety. They just need to be hired and asked to be looked at that. So with that, I want to thank you very much for your time, and yes, wish you all a happy 4th of July. Thank you.